The James Webb Space Telescope has essentially sent Earth a colossal caution, and it's moving closer. This warning comes from the exoplanet Proxima b. With each new picture sent back, extra questions arise, leaving subject matter experts terrified. Every depiction from this distant planet makes us marvel more about the mysteries of the universe. Questions are arising about the potential threatening planet near Earth. Might there be a connecting pariah planet that has adversarial objectives? Could Proxima ever present a threat to our very existence? The subject of extraterrestrial life has captivated mankind for many years. However, with current technology, like the James Webb Space Telescope, it has turned into a question we can research more completely than ever before. Yet, the universe isn't making it easy to track down answers. We continue to use our best tools, such as the James Webb Telescope, to get brief looks at distant planets and universes, hoping to find signs that might point to life beyond Earth. However, we should be sensible. Each new picture and piece of data reminds us of how little we really know. While these discoveries could be amazing, they also highlight the enormity and complexity of the universe, leaving us with more questions than answers. Getting a handle on a far-off planet like Proxima b could reevaluate our place in the universe. For specialists in space science, this is exciting. But for the general populace, it often feels like just another piece of space news, distant, conceptual, and at times overwhelming. These discoveries raise more questions than they answer, leading many to wonder how this influences life on Earth. Could Proxima ever harbor life, or even intelligent life, that could one day present a danger to us? Despite the colossal power of the James Webb Space Telescope, it can show us so much. Sure, we've learned some incredible things, like the fact that we now have stunning new pictures of Proxima b, and we know that the universe is vastly greater than we ever imagined. But what comes next? The implications of these discoveries can feel as immense as the universe itself. Proxima b, discovered in 2013 due to its gravitational interaction with its star, was a huge scientific leap forward for many scientists. Finding this exoplanet was like finding a new neighbor. Proxima b is just slightly larger than Earth, and it orbits its star every 11.2 Earth days, making it a fascinating subject for further study. From a scientific perspective, the possibility of a far-off world so near our own is exciting. But for many, it's hard to connect with a place that's 25 light-years away. To put that into perspective, even the fastest rocket ever built would take several centuries to reach it. Imagine what it might be like to stand on Proxima b. A star, Proxima Centauri, would appear as a faint red light overhead, much cooler and darker than our Sun. Proxima b orbits quickly to the point that a year there lasts just slightly over 7 Earth days. One side of the planet always faces the star, meaning it is permanently exposed to light, while the opposite side is covered in eternal darkness. It sounds like something out of a sci-fi novel, but the reality would be much harsher. On the bright side of Proxima b, any water would likely boil into steam due to constant exposure to heat. On the dark side, water would freeze into solid ice. The planet star, Proxima Centauri, is also not a quiet and steady neighbor like our Sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't the kind of place where humans would want to set up camp. Interest in finding life beyond Earth peaked in late 2020 when scientists detected an unusual signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which caught everyone's attention. Such a signal could, in theory, be a sign of advanced technology. However, it is far too early to make any conclusions. More recently, the James Webb Space Telescope has sparked even greater excitement by suggesting that Proxima b could have water vapor in its atmosphere. Water, as we know, is a crucial component for life. Its presence could be a game changer. To better understand how much water is present on Proxima b, researchers are using advanced techniques like spectroscopy. This method allows them to detect the gases surrounding the planet. Acting as a cutting-edge analytical tool, By studying the planet's light spectrum, scientists can identify specific gases like oxygen, methane, and carbon dioxide, which are all essential for life. Atmospheric modeling is another key approach. By creating simulated profiles of Proxima's atmosphere, researchers can make educated guesses about its conditions. These models serve a similar purpose to how scientists use dinosaur fossils to predict what ancient creatures may have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the incredible diversity of life on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme conditions: boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These resilient creatures prove that life can adapt and thrive in conditions once thought impossible. Could life on Proxima B be just as robust? The search for life on Proxima B presents enormous challenges, not only in space travel, but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Moreover, the distances involved are immense, meaning new kinds of propulsion systems are required to make space travel to Proxima B feasible. Concepts like solar sails, particle drives, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their early stages and require extensive research before they can be used in real missions. While dreaming about future space travel is exciting, we need to stay realistic. Finding life on Proxima B is full of technological and scientific hurdles. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This pursuit is not just about satisfying curiosity. It's about pushing the boundaries of human achievement. Could we one day set foot on Proxima B, or even make contact with life there? As we contemplate the long journey to Proxima Centauri and the search for extraterrestrials, it no longer feels confined to the realm of science fiction. Rather, it seems like a tangible, real possibility. This fascinating shift from a distant dream to a scientific endeavor has attracted serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are committing enormous resources to transform what would traditionally be an incredibly long journey, one that could take centuries, into a mission achievable within decades. The goal of reaching another star system within a human lifetime has sparked development and optimism among mainstream scientists. However, these lofty ambitions are quickly tempered by the obvious realities of our current technological limits. Despite significant progress in space exploration, traveling to Proxima Centauri, indeed LLP, then just 4.2 light-years away, still presents huge challenge. However, even with these visionary projects, the path to interstellar travel remains fraught with challenges. The concept of laser-driven sails, which relies on powerful lasers to propel ultra-lightweight spacecraft to a significant fraction of the speed of light, holds great promise. Yet this idea is still in the early experimental stages, and there are many hurdles to overcome. Engineers need to solve problems related to the power of the lasers, the durability of the sails, and the accuracy needed to guide such small spacecraft over vast distances. If these challenges can be overcome, a spacecraft equipped with laser sails could travel to Proxima Centauri in just a few decades, a monumental achievement in space exploration. This would be a dramatic shift from our current understanding of space travel, which is limited by the speeds achievable with chemical rockets. The dream of reaching another star system in a human lifetime could become a reality, opening the door to countless new opportunities for scientific discovery and the potential for interstellar colonization. As these projects evolve, there is also the question of how we would communicate with spacecraft sent on such long journeys. Even at the speed of light, signals sent to Proxima Centauri would take over 4 years to reach their destination. The delay in communication would pose significant challenges for any mission, making real-time control or adjustments nearly impossible. The reliance on pre-programmed instructions and the ability to monitor and troubleshoot from Earth would require a level of autonomy that current technology can only dream of. Despite these obstacles, the pursuit of interstellar exploration continues to inspire scientists and innovators around the world. Many believe that reaching Proxima b or other distant exoplanets is not just a scientific goal, but a necessary step for the survival of humanity. As we confront challenges on Earth, such as climate change, resource depletion, and overpopulation, the possibility of finding a new home in the stars offers a beacon of hope. However, even if we one day reach Proxima b, the challenges of survival on such a distant and hostile planet will still be enormous. Any potential colony would need to be self-sustaining, capable of providing food, water, and shelter in an environment with extreme temperatures and dangerous radiation levels. The development of life support systems, advanced medical technologies, and sustainable agricultural practices would be essential for any long-term human presence in space. In the end, the journey to Proxima b and beyond is not just about discovering new planets, but about pushing the limits of what humanity is capable of achieving. It represents the ultimate test of our creativity, ingenuity, and resilience. As we look to the future, the pursuit of interstellar exploration serves as a reminder of the vast potential of human achievement and the enduring quest to understand our place in the cosmos. Impel a little rocket to velocities of up to 20% the speed of light. While this idea shows promise, it is still in the test stage and faces various specialized and calculated obstacles. For example, it should beat the risks presented by space trash and guarantee dependable communication over huge distances. The fantasy about coming to Proxima Centauri and potentially finding extraterrestrial life is closer to reality than ever before. Yet it remains grounded by the limitations of current technology. Speeding up a rocket to approach the speed of light with present instruments feels almost unimaginable, like attempting to solve a difficult riddle in the dark. Even strong projects like Starshot, which intends to shoot a space apparatus toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it hard for space exploration apparatuses to work with the accuracy required. One proposed solution is the use of adaptive optics, smaller lasers on satellites that continually monitor and adapt to atmospheric disturbances. This system would help strong ground-based lasers stay focused on the spacecraft as it travels through space. However, the laser propulsion technique requires an enormous amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a brief period of time. Imagine setting up 100 million lasers over an immense region just to push a small spacecraft, just 33 feet wide, to 20% of the speed of light. At this speed, the rocket would still take 22 years to reach the Alpha Centauri system, a stretch of time longer than many individuals' lifetimes. However, the challenge of reaching Alpha Centauri isn't solely about overcoming technical barriers. There are natural obstacles too, such as the gravity of the sun, the presence of space debris, and the sheer vastness of the distance involved. All pose significant risks. Even communicating with a spacecraft on course for Proxima b would require sending messages through time. It would take around 4 years for a signal to reach it from Earth. Notwithstanding these staggering challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep yearning for discovery and exploration, rather than practical need. Even ambitious efforts like Starshot, which plans to send a spacecraft toward Alpha Centauri using lasers, face many practical obstacles. However, overcoming these issues could revolutionize space exploration. Still, the potential risks involved, including communication delays and natural hazards, require thorough preparation. Regardless of the challenges, many scientists believe the rewards far outweigh the risks. Finding life on Proxima b or another distant exoplanet continues to captivate minds worldwide. Finding life on another planet would be the most significant scientific breakthrough in human history. It wouldn't just reshape how we see ourselves and our place in the universe, but it could also provide insights into the origins and ultimate fate of life on Earth. While humanity dreams of a future where we can travel to the stars, we are also taking practical steps as we continue our search for life. The discovery of planets like Proxima b is just the beginning. Telescopes like Kepler have been critical in identifying distant worlds that might actually support life, by observing how these planets interact with their stars, either by blocking some of the starlight as they pass in front or by causing the stars to wobble due to gravitational forces. We can learn about their size, composition, and potential habitability. Now that Kepler's mission is completed, the James Webb Space Telescope is moving forward to take over its role. Its ability to detect infrared light allows it to study planets that were previously too faint or too far for us to investigate. As we learn more about Proxima b and other exoplanets, we are expanding our understanding of the universe, and with it, the possibility of life beyond Earth. The James Webb Space Telescope has opened new doors in the quest for extraterrestrial life, particularly with the discovery of exoplanets like Proxima b. While we are still in the early stages of investigating the potential for life on this distant world, the technology and curiosity driving us will continue to push the boundaries of what we know. Whether Proxima b harbors life, the journey to understand it has already reshaped our perspective on the universe and ourselves. As we dig deeper into the mysteries of the universe, the search for extraterrestrial life takes on new urgency and excitement. The advancements in technology, particularly in observational space science, have enabled us to peer further into the universe than ever before. Instruments like the James Webb Space Telescope are changing how we understand planetary systems, allowing us to explore the atmospheres of distant worlds and uncover potential signs of life beneath their surfaces. One of the most intriguing aspects of Proxima b is its location in the habitable zone of its star, where conditions could allow for liquid water to exist. This zone is often referred to as the Goldilocks zone, where temperatures are neither too hot nor too cold, establishing an environment suitable for life as we know it. Scientists believe that if Proxima b has the right atmospheric conditions, it might be capable of supporting living creatures, even if they differ significantly from those on Earth. Moreover, the study of Proxima b opens a window into the processes that may have deeply shaped life on our own planet. By examining the geological and atmospheric characteristics of Proxima b, scientists can gain insights into planetary development and evolution across different star systems. Such comparative studies could shed light on the processes that lead to habitability, offering clues about how life could arise in other conditions. Astrobiology, the field dedicated to the study of life in the universe, plays a crucial role in this research. Experts in this field are focused not just on finding life, but also on understanding its potential to adapt to extreme environments. This knowledge could improve our search for life in places once thought inhospitable, like the frozen moons of Europa or the methane pools of Titan. The fascination surrounding Proxima b is not only about the chance of finding life. It also highlights humanity's innate desire to explore and understand our place in the universe. As we consider the possible existence of intelligent life forms, ethical questions arise. If we were to encounter extraterrestrial civilizations, how would we communicate with them? What protocols would we establish to ensure mutual respect and understanding? The cultural implications of finding life elsewhere are significant. Such a discovery could challenge existing beliefs and worldviews, prompting a reassessment of humanity's role in the universe. It could also usher in a new era of collaboration, as nations and organizations come together in a shared quest for knowledge and exploration. As humanity continues to reach for the stars, the possibility of discovering life beyond Earth serves as a powerful reminder of our shared curiosity and collective ambitions. The search for extraterrestrial life not only expands our scientific understanding, but also invites us to reflect on the fundamental questions of our existence. What does it mean to be human? How do we relate to the cosmos and the other forms of life that may inhabit it? In the years to come, as our technology advances and we explore further into the depths of space, these questions will only grow more pressing. With missions like Starshot, the James Webb Space Telescope, and others, we are setting the stage for an era of profound discovery and connection, one where the boundaries of what is possible in space exploration are continually pushed. If Proxima b, or any other exoplanet, is found to harbor life, it would reshape not just our understanding of biology, but also our worldview. It could challenge the very notion that Earth is the center of life in the universe and lead to new philosophical and scientific inquiries about the nature of life itself. What if the forms of life we encounter are radically different from anything we could imagine? What if they defy our current scientific paradigms, forcing us to rethink the principles that govern biology and life processes? In addition to scientific curiosity, the search for life on distant planets can help unite people across the globe. It highlights the common human desire to explore and to understand the universe in a way that transcends national borders, cultural divides, and political differences. The idea that we are all part of a greater cosmic story is a unifying concept that could inspire future generations to work together toward common goals in science, exploration, and understanding. While we may be far from answering these grand questions, the journey itself is significant. The ongoing exploration of space and the search for extraterrestrial life reflect a deep, intrinsic part of humanity's nature. The drive to explore, to seek knowledge, and to challenge the unknown. The discovery of life on another planet, or even the evidence that life may have once existed elsewhere, would undoubtedly be one of the most transformative moments in human history. As we venture deeper into the unknown, we must remain mindful of the ethical implications of space exploration. How will we interact with other worlds? What responsibility do we have to preserve the integrity of distant environments and protect them from harm? These are important questions that must be addressed as we continue our pursuit of knowledge and exploration in the cosmos. Ultimately, the search for life beyond Earth is more than just a scientific endeavor. It is a reflection of our deepest aspirations, our relentless curiosity, and our shared desire to understand the universe and our place within it. It is an adventure that will continue to inspire, challenge, and unite humanity as we look to the stars and imagine a future where the mysteries of the cosmos are no longer beyond our reach.